Our topic is the introduction to mechanics. Now, when we see mechanics, this is the area concerned with the motion of macroscopic objects. The force applied to the object result displacement, or we have the change in position relative to its environment. So, for example, suppose we have the object whose mass is m, and this will be interacted by a force. So, the two particles interacted, the applied force from other particle with a mass, and this object whose mass is equal to m. So once these two particles interact each other, then therefore if the force is enough to have a change in position, then there will be a motion. So for example, so the applied force is able to move the body with the displacement, so therefore we have the motion. So the motion is actually part of the mechanics. Now the motion results velocity. Okay, so these are the quantities after the interaction between the two particles applied by this object applied by force. Then if we have the velocity, then we have the acceleration. And the acceleration is a change in velocity per time, where this velocity is the change in position with time, but acceleration is the change in velocity per time. Aside from this, we have the work done. Work is done on this object because of the force applied and the change in position. And there's also an energy. So there are two kinds of energy in mechanics. We have the gravitational potential energy and we have the kinetic energy. The potential energy is possessed by vertical height. In this case, there's no change in potential energy, but there's an energy with respect to a certain height, gravitational potential energy. The velocity provides the kinetic energy. So therefore, because of the interaction, these are the possible results. Aside from that, we can also have another physical quantity, momentum. And this momentum is the product of the velocity of the particle while moving and its mass. So the greater the mass, the greater the momentum, and the greater the velocity, the greater the... These are the results. And we have also the torque. It will produce a torque because of the application of force. This rotates because of the forces interact on this particle. So there are these are only few of the results or the physical quantities involving interaction between two particles, the applied force and the subjected force. So these are the mechanics. Now in studying physics, we need to have the idea first of the measurements. So in this video, we'll learn or review the measurements. Then we have also the conversion of units. Then we will recall the fundamentals. Then after that, we will study the physical quantities of the particle, and we will proceed to the basic information about the vectors. Okay. In measurements, actually, this is dealing with the question how large and how much. So when we say how large, how much, then it leads us to have the process of measurement. So to answer this question, how large, how much, then the answer is measurement. Now in measurements, we have two kinds of systems. The system of measurements, we have the metric system and we have the British or English system. The metric system was divided into two. We have the CGS or centimeter gram seconds, and we have the MKS. This is the old unit, meter kilogram seconds, but now we call this as SI. the international standard, or the old name is System International. So SI is the dominating unit in this generation. So when you are measuring length, then we have the meter. For the mass, kilogram, then the time is seconds. By the way, the CGS is also working in the laboratory. Usually yung small object analysis, then we will use the CGS in the laboratory. Centimeter for the length, grams for the mass, and we have still the time is in seconds. But the traditional unit is the British. This is the old before metric system. English system is already working on area. So they call this as FPS. F means foot, pound, seconds. So okay, now in dealing with problems in physics, there are only 7 fundamental units. Okay, and these are the important quantities. When we say mass, we have this big letter M, and we have the kilogram as the unit. For the length, we have big letter L, and we have the unit is in meter. The time, in symbol big letter T, we have the S, small letter S, this is in seconds. And in current, symbol I, the unit is ampere, A, or AMP. For the absolute temperature, or let us say temp, the unit is in Kelvin. So Kelvin is the absolute unit. In luminous intensity of light, we usually have a symbol of L sub V, and this is candela, CD. For the amount of substance, microscopic particles, then we have the number of moles, macroscopic or microscopic. If we are dealing with the amount of substance, the unit is in mole. Okay, so these are the 7 fundamental units, but mixing these fundamental units will provide another physical quantity. Now, if we are analyzing, because we are in mechanics, so we are only concerned with the mass, length, and time. So if we are mixing these 3, then we are actually on the dimensional analysis. So we call this as the MLT system, the mass, the length, and the time. So these are the 3 fundamental units in mechanics. So for example, I want to divide the length by time. So length by time is a physical quantity, and this is, take note that the length is meter and this is second, so this physical quantity is velocity. So velocity in dimension analysis, call it as L over T, and the unit in SI, meter per seconds. Now this actually, the result of this combination, if you use another dimensional units, then you can form another quantity. For example, if I divide this LT by T again, so the result will be L over T over T. Mathematically, this will result L over T squared. So L is what? Meter. T is second. So this will provide the units of meter per second squared. Meter per second squared is acceleration. Okay? So there are many possible quantities that can produce using these 3. So the LT over T, or L over T squared, is actually the acceleration, and it has the unit of meter per second squared. There are many quantities that can be formed on this L or MLT. Suppose I will multiply the mass. I will multiply the mass with the acceleration. Take note that the product of the mass and acceleration in your previous physics is called, we call that as the second law of Newton. Result is force. So meaning, if I multiply the m by L over T squared, it will produce what? It will produce multiplying mass and or m times L over T squared, it will produce an acceleration. Okay? So this will become ml over T. So ml over T squared in dimensional analysis is force. So if you analyze the unit, m should be kilogram, L is in meter, so this is kilogram meter per second squared. Kilogram meter per second squared. But take note, this is Newton in short, because 1 Newton is 1 kilogram meter per second squared. Okay? So there are many possible quantities that can be formed out of these three. For example, I will raise this L 2 times. The result is, the L squared is area, and the L cube is volume. If you divide the mass over volume, it should be kilogram, it should be m L cube, m over L cube. So again, these are the basic or the fundamental units in mechanics. This is very useful. Okay, aside from that, we need to have the ability to convert. Now the SI uses the prefixes, so you have to review this one. If you are measuring a higher number, then go for this prefix. For example, by the way, the base unit is 1, so these are the prefixes. If your dimension, if your unit is in meter, then going upward, use kilometer or megameter or gigameter. Now, if that particle has a smaller size in size, then use the lower prefixes. So use centi, milli, micro, pico, and so on. Nano. Now take note that in order to make it convenient, because you will be working with this number of zeros, so it's advisable to use the power of 10. So review your ability in work in the law of exponent, because you will be dealing with the law of exponent. This will serve as the conversion factor, and this is very handy because you can use any. You can use L, M, T, or combination of the quantities. Now, these are also very important in terms of conversion because, okay, we are using the SI, but there are problems that involves English system. So, with that, you have to memorize the very important basic conversion. These are basic. For example, 1 inch is 2.54. This is English system, and this is CGA system. So we have also the yard and the meter, the mile and the feet, or in kilometers. So be familiar with this conversion. These are very much useful. Then the 1 pound force is 4.448 or 5 newtons. Or the 1 dyne is 10 raised to negative 5. Now take note, 1 meter is 3.28, and the 12 inches is 1 foot. So these are this can be used whenever there are problems that involves mixing of units. So before going to simplify or to answer the problem, you have to be consistent with your units. So you cannot solve the problem mathematically if the units are inconsistent. So you're advised to review. Okay. Anyway, we have this review of the conversion to ensure your knowledge. So how to convert? This is the basic, and this is only simple conversion. So for example, you are asked to convert the 100 pounds per cubic foot to grams per cubic centimeter. Now take note, this is the unit of English system or British, while this one is the CGS or in part of the metric system. So how to convert this unit pound per cubic foot to grams per cubic centimeter? First step, you have to recall the conversion factor. So think of a conversion factor that can convert this pounds to gram, feet cube to centimeter cube. Okay? So, recall the factors. Now, take note, the 1 pound is 454 grams. Okay, so you should memorize this one. And the basic conversion, 1 meter is 3.28 feet. So, in this conversion, you cannot convert a meter to feet. So, we have this meter of feet, then it can be converted into meter. Then from meter, we can convert this to centimeter. So therefore, these are one of the conversion. There are many conversions that can be used. For example, you can convert feet to inches, then inches to centimeter. So I chose this value of conversion factor, but this is not the only conversion factor. But okay, so far, if you are solving this problem, this is already solved because of this factor. Now, the next step is to multiply the ratio of the factor because the sign of equality says in physics they are equal. So, the same meaning. So, take the ratio of this because the ratio of this is 1. Okay? So, for example, the 100 pound per cubic foot, we will multiply this by 454, use this conversion by pounds by 1 pound. So, in this case, this nothing to worry as far as mathematics is concerned because this is 1. In physics, this is 1. So therefore, in mathematics, this is not, this factor is actually equivalent to 1. So if you multiply 1 to this factor, they are equal in physics. Okay? Now, take note that we can reverse this one. This is also 1. If this is 1, this is also 1. But look at this one, we cannot convert this one. Pounds. We cannot cancel, so the unit becomes very inconsistent. Okay, so therefore you have to force to use this ratio because we can cancel the pounds. So pounds now becomes grams. Okay, so then multiply again, convert this feet to meter first, then meter to centimeter later. So therefore, okay, so if we divide 3.28 by feet by 1 meter, this is 1, nothing to worry. But the question is, can you cancel the feet cube? Okay, and this is only feet, and this is feet cube. So therefore, we still have 2 here. So all you need to do is to use your algebra. Okay, you have to cube it so that applying the law of exponent, this becomes 3.28 cube, and this is feet cube. So this feet cube can be cancelled. So in this case, if you cube both the numerator and cube the denominator, the same answer as far as algebra is concerned. So therefore, there's nothing to worry. So then you can cancel the feet cube, but you cannot cancel the number. The number is 3.28 raised to 3. So this is still the number. The feet cube will be cancelled to this feet cube, but we still have the 3.28. Then, okay, converted to meter, then meter to centimeter. So look at this one. In 1 centimeter, 1 meter, there are 100 centimeters, or the 10 raised to negative 2 meter is 1 cm. You can do it. So therefore, cube it in order to cancel the meter cube. Then the remaining unit is only what? Gram per cubic centimeter. Okay? So we arrive this unit because others cancelled, but we leave this grams and we have the cubic centimeter. So all you need to do is to use your calculator, multiply 454, okay? 454 by reminders. You have to cube this one. So 3.28 cube times 454. Then divide it by 100. Cube this before dividing. PIMDAS power is the first. So therefore, cube this, then divide from the result above. So the result is 1.6 grams per cubic. This is how to convert. Okay, I know this is review, but this is to ensure that you will have that ability to convert, because without this knowledge, we cannot go forward on the topic of the mechanics. So let's discuss now the physical quantities. The physical quantities are divided into two. We have the scalar and we have the vector. When we say scalar, this is only specified by magnitude only. So therefore, if you want to describe the quantities belongs to scalar, magnitude is enough. But for vector quantity, this was divided. This vector cannot be described by magnitude only. Okay, it's not enough. Uh, we need to specify, aside from magnitude, we have to provide the direction. So quantities that needs to provide both magnitude and direction are vectors. But if it can be described by magnitude only, then call it as scalar. Okay, so there are many quantities. You can say it millions of quantities. There are many quantities that can be produced from the physics problem. But all those physical quantities was divided into two only. The scalar classified into two. Scalar and the vector quantity. Okay? So, for example, the example of scalar is time. The time doesn't need direction. Okay? So, no need to provide north, east for the time. So, therefore, this is purely scalar. Aside from that is temperature. Temperature, there's no direction. So, this is a scalar. The mass also is scalar. Remember, mass is the quantitative measurement of inertia. This is scalar. There's no direction. Now, our mass in Earth is the same mass if we are on the moon or in other planets. Mass is the amount of inertia. Okay, the inertia is the property to tend to resist. So the bigger the inertia, the bigger the mass. So this is actually scalar. Distance is also scalar because distance is between 2 points, the length between 2 points. Okay, then density is also scalar. It doesn't have the direction. So there are many quantities that can be that belongs to the scalar quantity. Now what about force? Vector. So force is one of the example in vector's quantity. Why? Because force, we cannot describe the amount of force only, or the amount of magnitude of force. For example, you see an object applied by a force and the object was displaced. So to describe it is you need the magnitude. You say it, the object was displaced because of the force. Is that enough? The answer is no. It is not enough. Why? Because the displacement, it can be going to north or maybe going to the south. If you have the magnitude applied to that force, there are many possibilities to displace from that point, the initial point, to the final point. So in order to describe clearly, we need the direction. So force is obviously a vector quantity. Electric field is also, we are studying about electricity, then electric field is a vector quantity. Weight, okay, this is very important. Sometimes there are misconceptions occurs on the learners because they attempt to equate mass and weight. Remember that mass and weight are different each other. Weight, by definition, this is the force of gravity applied to the object. So for example, our weight, we have the weight, and this weight is the force applied by Earth. If we are on the moon, surface of the moon, then our weight is different weight if we are in Earth. Why? Because Earth has 9.81 gravity, while the moon is only 1.67. So therefore, our weight in Earth is different weight on the moon. So, but our mass is the same. Okay? So therefore, this must be, by the way, weight is directed towards the radius of the Earth because it is the force that the Earth exerts on us. So therefore, this must be vector. It's not enough to describe the magnitude only. The relationship between the two is actually weight is mass times the gravity. And the gravity depends on the planet that we stayed. Because the object will create gravitational force. So large objects will generate gravitational force. The Earth has the greater uh, gravitational acceleration because it has a greater mass compared to the moon. But the Earth has less gravitational acceleration compared to Sun because Sun is very large by compared to Earth. In fact, the gravitational acceleration of the Sun is 274. Compare it with 921. So therefore, the larger the mass, the larger the gravitational acceleration. So if you have the larger gravitation, then you have also the larger gravitational force applied to any object. And we call that as weight. Okay? Now, another misconception, of course, on distance and displacement because somebody equate these two. So if you are asked, is distance equal to displacement? The answer is no. They are practically different to each other. One is, distance is a scalar, means this is only distance, length between points. While displacement is different. This is vector. And displacement by definition, this is change in position. When we see position, it has initial position and final. The initial and final cannot be interchanged. And again, displacement is a change in position. Change means final minus initial. You cannot say it initial minus final. So therefore, displacement is a vector quantity. Aside from magnitude, we need to describe it in terms of direction. Okay? So I hope this is clear. Also with the velocity and speed. Okay, speed is scalar. Velocity is vector. Okay? They are not equal. Now, if the particle moves in a straight line, okay, then the magnitude of the speed, the magnitude of velocity is the speed. That's the time that they are related to each other. Or the magnitude of velocity is speed. Okay? That is the relation, but they are not equal. So there are many quantities. Now, here comes the problem. And no problem as far as scalar is concerned if we are dealing with, because in physics, we will be combining two or more quantities. For example, length, displacement, big forces, we will combine that. We need to combine. So in order to combine, you have to analyze first if it's scalar or vector. So if it's scalar, nothing to worry because we can use the algebraic method. Addition, subtraction, multiplication, division. Okay, ordinary. For example, the length, you have to accumulate all the lengths, then add algebraically. Now, the problem occurs on vector because talking with combining vectors, okay, when you say combining, you have to use the geometric method. Algebraic method is different from the geometric because geometric involves angle. The algebraic doesn't involve an angle. Okay? Doesn't involve an angle. But geometric uses an angle. So, you cannot equate the two. Summing up scalar and summing up all vectors or vector sum. Then the vector sum should be in geometric method. Okay? So, you have to be careful of that's why you need to analyze first before going to solve. Analyze first if it is scalar or vector. If it is vector, then geometry. If it's scalar, algebraic. Okay, so I think the problem occurs on the vector, not on the scalar. So therefore, we have one topic in this lesson in mechanics is the vector sum or the vector addition. Okay, now remember this vector addition, this is geometric. So therefore, vector sum is a geometric sum. Now, it is good to have the mathematical notation because we will use symbols. Okay, when you say vector, it has tail and it has tip. The tail is this point, and the tip is the tip of the arrow. Okay, so the arrow signifies direction. The tail to tip distance is the magnitude of the vector. So this is a vector presentation, graphical presentation of vector. So if we have P1, point 1, and this is point 2, the vector measures from point 1 to point 2. Okay? So the length of that is the magnitude, and the arrow signifies direction. So this is the graphical illustration of a vector. Okay? So suppose I have this point. Sometimes there's a problem. Okay, we start at this point. Then this point was displaced at this point, then move at this point, then stop at that point. So there are 5 points, locations of the particle while traveling from 1 to 5. So it arrives at point 2, point 3, point 4, point 5. Okay. So the question is, what is the total distance and the total displacement? So this is very important question. Okay, so take note that distance is scalar, displacement is vector. They are not equal. When we see total, the total means depends upon the quantities. Remember, this is scalar, so this should be, it can be applied by algebraic sum, but the displacement, it should be geometric sum. Take note, they are not equal. If the question is, find the total distance and displacement from point 1, this is the point 1, to point 2 or 2.4 of 0.5 of travel. So take note, it reaches these points. Okay? So how will you answer the total distance? Okay? The total distance is, you have to sum up this algebraically. That's it. If you have the informations of the distance between 1 and 2, 2 and 3, 4 and 5, 3 and 4, 4 and 5, then use the arithmetic sum, then that's it. That's the total displacement. But what is the total distance, sorry. But what is the total displacement? The total displacement is, it starts from 1, because this is the initial. Remember, displacement is the change in position between initial and final. So it should be from point 1 to point 5. And you have to connect this by a straight line. And this is the displacement. Okay. Mathematically, are they equal? Is the total distance equal to the displacement? The answer is no. They are not equal. Okay. They are equal if this is moving in a straight line. Okay. They have the same magnitude, but they are not equal. Same magnitude, but it has the direction for displacement. So all you need to do in order to answer this one, you have to use the geometric. So when you see geometric, you will be dealing with triangle. You have to break this into several triangles. For example, write a triangle or line that connects, yeah, then line that connects this one. So this polygon, 1, 2, 3, 4, 5 sided polygon can create 3 triangles. So you have to use your trigonometry, working with an oblique triangle, then solve this side, then after that, use this side, and use this side, provide a solution with triangle, then after that, after solving this side, then use this last final triangle, and you can solve for the displacement. You can solve this displacement only provided that the length of the travel from 1 to 2 and its angle should be provided. Because take note, this is position. Position 1 to 2. 2 to 3 position. Position is a vector. So this is position. So it should have the magnitude and direction for every positions. And the final position is the 5. So the change in position, it's coming from the change in position, which is the displacement, coming from point 1 to point 5. So therefore, this should be the displacement. Okay? So, a lot of mathematical process like trigonometry is very much important to this topic. Finding the vector sum using triangles. So, that's it. This is the difference between the total distance and the total displacement. Okay? So, if we have this vector, sometimes we have the vector equal vectors. What is an equal vector? Suppose I have vector, this one, from point 1 to point 2, call it as vector B. Now remember, in mathematics, this is the graphical presentation of vector. They have the tail and tip, but mathematically written, a letter variable with an arrow above is vector. So this is a vector. Understood? Without the arrow, without this drawing, and you have seen this one, this is understood that there is a tail and there is a tip. So therefore, there must be magnitude and direction because this is vector presentation. Now sometimes, you can use the bold letter. So you can ignore the arrowhead, remove the arrowhead, but this should be written in a bold. So other references use this bold letter, but along the way, when we are working, we are studying about mechanics. I used to have the arrowhead. Okay, so these are mathematical symbols for vectors, and this is the graphical symbol, the arrow. So suppose we have these parallel lines. Okay, then I have another vector, call it as vector A. So this is arrowhead. Now suppose, because this is parallel line, suppose this angle is the same as this angle. So therefore, geometrically, we have two parallel lines cut by transverse lines. So therefore, these two lines must be the same magnitude. So we have this angle equal to this, and the length of this and this is the same. Okay, and the arrow is pointing this direction, this arrow. So therefore, we can say that vector B and vector A are equal vectors. Now, vectors can be called as equal if they have the same magnitude and the same direction. Take note, the same magnitude, the same direction. So therefore, we call that as equal vectors. So we can say that vector A is equal to vector B in that case. If vector B and vector A have the same magnitude, then the two vectors are equal. So in that case, you can move this anywhere as long as you maintain the magnitude and its direction. They are equal. They are equal. Now suppose I have another vector, call it as vector B. Same angle, same distance line, but take note the arrows reverse. So is vector B equal to vector A? The answer is no. Why? Because the requirement of having an equal vectors, it should have the same magnitude and the same direction. Now in this case, they have the same magnitude, but they are of the different direction. So therefore, vector B is not equal to vector B. Okay? But you can call it, we can use the sign of equality, but it is a negative inverse. Okay? Negative inverse. This means that they have the same magnitude but in opposite direction in this case. This is the relation between the two. Additive inverse. Okay? So, equal vectors. What is equal vectors? Vectors that have the same magnitude and the same direction. Okay, now, when you are working with vectors, sometimes we need to have the magnitude of that vector. Take note, this is vector. What is the magnitude of the vector? Now, mathematically, magnitude of vector is written as you have to construct the absolute sign and put the vector inside the absolute sign, and this is mathematically our magnitude of vector B. So it describes the length between these 2 points only. It doesn't have the directions. Therefore, this is now already scalar because magnitude is a scalar quantity. So therefore, you can do this for the magnitude, absolute sign, or simply remove the sign, arrowhead, italize it, no absolute symbol. So therefore, this is already the vector. Okay? So that's it. Remove the arrow. In our case, remove the arrow. That's the magnitude. With the arrow, then it is vector. Okay? Take the absolute sign. Now, aside from that, in studying vectors, be sure to have the idea what are parallel vectors and anti-parallel vectors. Knowledge in parallel and anti-parallel vectors very, very important, because in summing up vectors, we will use, or we can use the polygon of vectors. So there you need the idea of having parallel vectors and anti-parallel vectors. What is parallel and what is anti-parallel vectors? Okay, suppose I have this vector A and we have vector B. Okay, what's connected on the vector B is connected on the tip of vector A. Then we have another vector C, but the C was the tail of C is connected at the tail of A, and the tip of C is connected to the tip of B. So therefore, there are three vectors. Now the three vectors forming polygon of vectors. This is a closed polygon. Okay, this example is a kind of closed polygon. So therefore, we have this a triangle. Okay, or a polygon. Now, you can call this as polygon of vectors, but the polygon of vectors can be converted into concurrent of vectors. How? You have to construct the equal vectors and place it on the tail. So you can notice that this is no longer a polygon of vectors. We call this as concurrent of vectors. Concurrent means that lines have a common point, and this is the common point, and this is the tail of the three vectors. So we call this as concurrent of vectors. Okay, so therefore, in other words, using the principle of equal vectors, we can transform the polygon into concurrent. Okay, or you can construct another polygon. So we can construct, if we move this vector A and place this vector A at the tip of vector B. Okay, so let's do it. Remove this one, then transfer. Take note, we did not change the direction and the magnitude. So therefore, this is still the vector A. And this time, we have another closed polygon. Okay? So therefore, in other words, we can reconstruct geometrically the vectors as long as you maintain the magnitude and the direction, the word equal vectors. And using that, we provided another form of polygon. It's different from previous. Okay? So, there are many ways to create a polygon from the vectors given. Now, this is very important principle. In a closed polygon, because this is a closed polygon, sometimes open, okay? But for the closed polygon, if you sum up all the vector sum should be 0. So therefore, if you are constructing a polygon, then after constructing, it returns to the final point, initial point, then the vector sum is 0. So take note, these are vectors, 3 vectors. So we can say that the vector sum of these 3 vectors is equal to 0. This is by principle. Now, how will you do it? Okay. Now, you can use this statement using the parallel and anti-parallel definition. So, if that vector is parallel to another vector, then it follows the tip and tail combination. What does it mean? Look at this one. Suppose I start here at this point, then move to the tip of B. So this is parallel vectors. Why? Parallel. This is parallel. Why? Because it starts from tail and it ends up with tip. So therefore, this is parallel vectors. Now, moving again forward, you have to close the polygon. So you have to think of a water that flows into this line. So this is a parallel along the line, and we have this arrow. Okay, this is parallel vectors. And this is parallel vectors positive. Okay, for anti, negative. So therefore, this is the tail of A, and this is the tip. And the flowing of water is going this way. I use the analogy of water to make it simple. So therefore, this is parallel vector. So therefore, A and B are parallel vectors. If they are parallel vectors, both of them are positive. Now, continue. You have to close the traverse. Okay? Close the traverse. Because this is a closed polygon. So then, you are now moving against the direction of C. So this is not the tail of C. This is the tip. So therefore, this is anti-parallel against the flow. So this must be minus. So mathematically, this geometric presentation of three vectors can be converted into a mathematical sentence. Okay? So we can say it in mathematics. This is parallel vectors, yes, plus. This is parallel vectors, yes, plus. So you have to add this one. Okay? And we call this is vector sum, actually. Then, this is anti. So this should be minus. So this is parallel vectors, and this is anti parallel vectors. Now, we started at this point, and we end up to this point, and we have these three vectors. Now, using this principle, equate this to 0. The sum should be 0. So this graphical presentation here, three vectors, this is the mathematical expressions, and they are equal. So if you have this mathematical sentence, you are now already constructing this graphical. They are equal. So you can ignore the polygon and use this one mathematically. Now, if we are working of these mathematical equations, then we can now find a vector sum, because our target is to, this is a vector sum of three vectors. So do it in vector algebra. All you need to do is to transpose. If you are solving, remember this is a vector sum, so you have to transpose this one to the opposite side. Okay, becomes plus, because algebra additive inverse. Okay, you can use the algebra principle. Transposing becomes change the sign. So therefore, this will become positive. So in other words, the vector sum of A and B is C. Okay, so this is actually the process of transposing is vector algebra. So therefore, we can say that C is the vector sum of A and B. So look at the drawing. This is mathematical expression. This is graphical. This is vector A connected by vector B. So therefore, this is the vector sum. That's it. Very clear. So we can say that this is actually, you can express, no? We are now, from this equation, we express C in terms of A and B, and we found out that C is the vector sum. If this is minus, C is the vector difference of vector A and B, and so on. So this result is called as the vector sum. So this vector sum is the same as this one, vector sum. Okay? So the requirement of providing the vector sum is actually using the polygon. We are required to produce a polygon or a concurrent of vectors, because concurrent vectors can be converted into polygon. And the polygon, we will use the principle of closed polygon. If that polygon did not close, okay, so therefore you can compute the closing line. The closing line is the vector sum from the initial point. We can study that in the polygon method of finding the vector sum. Okay, so expressing, so we can express one vector in terms of the other. Very important, because that is vector algebra. Okay, to exercise the principle. Suppose I have this problem. No, we have this network of vectors. These are we call it network of vectors. B, vector A, vector B, F, K, G, H, C, D, E. Okay, these are, now this actually, in actual application, this is actually in engineering problem, civil engineering problem, this is actually trusses for one possible trusses that you can create by a structure. Okay, so this is one member of the truss, another member this diagonal truss, and so on. It's vertical, okay, horizontal. So there are forces. For example, forces is so representing vectors. Okay, now our concern is to find the relation. What do you think? What is the relation of C in terms of this vector D in terms of this vector E and this vector F? Take note this is a closed polygon. Okay, look at the problem. Express C in terms of EDF. So this is a closed polygon. So therefore, we can apply the principle of closed polygon. So to answer this one is to use the uh, principle of a closed polygon. The vector sum of a closed polygon is 0. So we can start. So if we start at this point, then traveling at this point, then we can call this is a parallel vector. So this should be plus. This should be plus. Then continue. Now take note, we start this point. So we need to stop also at this point. The stopping point is also this point. Starting point, parallel vector, C. Then D is parallel vector. So therefore, it should be plus. It should be positive, parallel. D is parallel to C. Okay, so then continue. Okay, look at this one. This is against, imagine a water that is flowing. Okay, so just, and this is according to the current of the river. Okay, then this is according to current, but this is against. So you find difficulty in climbing up this current of water against you. So therefore, this should be minus. Your energy will be subtracted. So this should be anti-parallel. Anti-parallel is minus. Parallel are positive. So continue. This is now what? We are on this point. Now we are now to close the traverse, and this is parallel vectors. Take note, this is the tip. So therefore, this is plus. Okay, since we start here and we end up here, this is already a closed polygon, then equate this to 0 by principle, because the sum should be 0. Now, from this, we can easily use algebra, transpose, okay? You can transpose this side, okay? This is vectors algebra, transpose D, transpose F, okay? Then arrange, this is the answer. This is how we express vectors in terms of the other vectors. Now this time, this is not a vector sum. Okay, this is not a vector sum. But this is C in terms of the other vectors. Okay, so another example is C. CD, okay, CD key. We involve the key. CD key G. Is this the right problem? C, D, E. Okay, oh wait, sorry, this is a wrong problem. E, D. Okay, this is correct. G, K. So this is the closed polygon. C, D, E, G, K. Okay, this is a closed polygon. So therefore, we can express one vector to another. So this the problem expressing D in terms of this vector. So you can start at any point. By the way, the rotation is not necessarily clockwise, counterclockwise. As long as you decide to have that line as your starting point. So for example, I will start at this point. Okay? And this is along the flow. So this must be positive because this is along the flow. But moving towards E is that towards E. Towards E is another parallel. So therefore this should be positive. And this is negative. Okay? Because this is against. Then we have letter C. Letter C is again negative. This is negative. Against. And this is K is positive. Okay? K is positive. Then we already close the polygon because we start here and we end up at here. By the way, you can use any point. Will arrive the same. Then equate this to 0. Then use your algebra. Then we are able to solve this problem. Okay, so I think that's So these are very important principle, especially if we are analyzing vectors. So use the principle of polygon of vectors because the sum should be 0. Okay, so thank you. See you on the next video. Is talking about the uh, methods of finding the vector sum. So good luck.